today's notes are for day 4, and we're going to start by talking about lines and angles. Okay, so not all lines and planes intersect. Right now, quietly to yourselves, I want you to read through this. Okay? Okay, can somebody tell me an example? We're not going to move down to the exercises yet, but looking at this figure right here, what would be two planes that don't intersect? Okay, so on top here you have A, B, C, D, and that doesn't intersect with what other plane? Good, E, G, H, F. Okay, so those are like two planes that don't intersect. Good. Okay, what are some lines that are on the same plane and do not intersect? So like on the top one, A, B, C, D. Good, AC is parallel to BD. Good. Okay, the next one, we understand that this means parallel. Is that correct? All right. And lines that are not in the same plane and do not intersect are called skew. Can you tell me what is skew to CD? Or, I mean, not CD. Well, let's do CG. What would be something skewed to CG? Okay, EF. Is there another line that's skewed to that? Okay, EF. Oh, BF. I was thinking an AB. Yes? Good. Okay. Oh. All right. Exercises 1 through 3. Shade one set of parallel planes. So I think you guys can do this. Go ahead and try that on your own. Okay, so there's lots of different options, but if I shade that side, the parallel plane to that would be over here on this side. So can you guys see how those are parallel planes? All right. Trace one set of parallel lines with a solid line. So you can make any set of parallel lines. I'm going to go ahead and just make these two here on the top. So this line is parallel to this line. But if I wanted to, this line is also parallel to this one here on the bottom, right? Okay. And then we're going to do a skew line with dashed lines so that we can see the difference. So for me, one set of skew lines could be something like this. So this one right here, and it's skewed to this one right here. Because with skew, you don't want them to be parallel. So you want them to not be parallel and then not be on the same plane. Okay, questions there? All right, so in exercises 4 through 7, use the diagram to name each of the following. Okay, so I'm going to give you a minute to go ahead and write down. So you are going to write down a line that's parallel to RS. Is there more than one answer? Yes.
Do you write all of the answers?
You can write all of them if you want to. I'm going to write all of them, but if you just write one, that's also okay. Okay, so raising your hand, can somebody tell me one parallel line? Okay, Denise. Good, TU is a parallel line. Okay, can somebody else raise their hand and tell me? Okay, Josh. Good. PQ is also parallel. And there's another one. Dustin. Good. NO. Am I missing any? Okay, moving on to the next. A line that is skewed to QU. So I'll give you a few seconds here to write down one example. Okay, can someone raise their hand and tell me one? Okay, Dustin. Good. NO is skew. Anybody else have another one? Capo? PN. Good. PN works. Anybody else have any others? Okay. TO. Yes, TR. Thank you. Any more?
RS.
Perfect. All right, and that's all I have. Am I missing any? All right, so a plane that is parallel to NRTP. So NRTP is right here. So a plane that is parallel to that. Okay, Dustin. Perfect. OQUS. And we need to label 3 lines that are parallel to OQ. Christian. NP. Good. Denise, you have another one? Good. US is correct. And there's one more. Carlos. Good. TR. Now, could you write RT?
Yeah.
Yeah. So either way, it works. Okay, moving on to the next. They want you to state whether it's true or false. If it's false, you need to talk about why it is false. So number 8, in your groups, talk about those and decide if you think it's true or false and why. Okay, can anyone share out what you guys figured out? Okay, I agree. It is false. And why is it false? How can you prove that it's false? Caillou. Good. They intersect. Does anyone know where they intersect at? Where at? Perfect. They do intersect at IK. All right, number 9. Talk in your groups. What do you think? Okay, are those parallel? They are, so this one is true. The nice thing about true is if you don't have to explain. It's just true. Okay, 10. Okay, so what do we think 10 is? True or false? Very good, false. And why? Intersect where? Good, at point H. (11) Is FG parallel to line KI? It is false. How is it false? They are skewed. That would work. Also, I was thinking they're not on the same plane. So in order to be parallel, they need to be on the same plane, right? Okay, any questions on this page so far? No? All right, let's move on. Okay, can I have somebody read this paragraph right here at the top for me, please? Thank you, Christian.
shows line A and B intersect at a line X. Line X is the transverse. Transversely is the line that intersects two or more lines on the same plane. The angles formed are either interior angles or exterior angles.
Good. And we already talked about a lot of this yesterday, correct? So this should actually be a review. Do we agree? Yes? Okay. So we understand interiors on the inside. They actually listed all of those. Exteriors on the outside. They listed all those as well. Yesterday we talked about these as well. Alternate interior angles, alternate being opposite, correct? But on the inside. And then alternate exterior is alternate on the outside. Something new, same side interior, 3 and 5. Okay? So that's called same side interior. And so then there's also 6 and 4. And then we talked about corresponding yesterday. Okay, so we're going to skip down to these exercises. So starting with number 12, name all pairs of corresponding angles. What does corresponding mean?
Same side.
Good.
Side.
Very good. Okay, so in this case, what would be the corresponding angles? Good. Yep, 1 and 5. And I decided I'm not going to do that line through the angle anymore because it's just taking up more time. So we're just going to do the angle 1 and 5. That's much easier, right? Is it easier to look at too? Okay. And then I have angle 2 and 6. And angle 3 and what? Good. And angle 4 and very good. Okay, name all the pairs of alternate interior angles. So I'm going to give you about 10 seconds to write those on your own first. Okay, can somebody share out one of the pairs? Okay, Denise? 1 and 8. Alternate interior. So that's exterior. I'm going to skip down though. Alternate exterior, that would be 1 and 8. So remember, exterior is on the outside, interior is on the inside. Okay, can somebody else give me? Hannah.
4 and 6.
Good, 4 and 6. The other pair, Robert.
3 and 5.
Good. Okay, and it sounds like most of you are kind of ahead of the game on some of these. So name all pairs of same side interior angles. So we're only looking at the interior, same side angles. Anybody have one pair? Okay, Dustin?
Would it be 4 and 5?
Yes, 4 and 5. Good. And the other pair? Nucia. Good. 3 and 6 is correct. Okay, and the last one for alternate interior or alternate exterior angles. What is the other pair? Josh. Perfect. Okay, do we have any questions there? All right, 16 and 17. They want you to label what those are. So 1 and 5.
Alternate exterior.
Good. Alternate exterior angles. Okay, I'm going to give you a second to think about 4 and 6. And Caleb.
On number 15, isn't it supposed to be 1 and 8?
Yeah, it is a 1 and 8. You just can't read it very well. But it is. Thank you. It kind of looks like a 4, but it's just the angle in front. Okay.
Same side interior angles.
Very good. Same side interior angles. Okay, any other questions or comments on this? No? All right. We're going to move on to parallel lines of triangles. Okay, so one of the most important things for you to remember in this class, well, actually, they're kind of two, but straight lines equal how much? Okay, and if you don't remember this, or you might want to make a note, straight lines equal 180 degrees. Also, triangles add up to be 180 degrees. If you remember that, that is a lot of what we do, okay? So they give us the steps here. We know that measure angle 1 plus DAB, those two, they add to be 90 degrees. And you can see here how it makes the box that it's a 90-degree angle. That is angle addition postulate. You're adding two angles together, okay? Then they substitute in measure angle 1 plus 30 equals 90, so that we can solve to figure out what measure angle 1 is, okay? Then you subtract the 30 to both sides, subtraction property, in order to find the answer, okay? Do you see how it moves from one to the next? Like from here to here, they use substitution. From here to here, or sorry, yeah. And then when you got from here to here, they subtracted in order to get the answer. Okay, also, if you notice, and what's really nice is that, you know, these are your proofs, right? And so you can always use your notes to go back and look to see, okay, what did they label that, to figure out what the reason is for steps. So on this step, they're telling you that measure angle 1 plus measure angle 2 plus measure angle A, B, C, those all equal 180 degrees. We know now, because we figured out right here, that measure angle 1 is 60 degrees. So they substituted in 60 for measure angle 1. So now we have 60 plus measure angle 2 plus 6 equals 180. So the next step is addition property. And that's just because we combined our like terms. Could we also put combined like terms here? Yeah, that would also work. And so 60 and 60 is 120. And then the last thing we would do is subtraction property in order to find out that measure angle 2 is also 60 degrees. Okay. Do we need to write out all those steps when we're doing these problems down here?
No.
No. I just want you to find the answers. Okay? So, one thing that is important for you to remember in triangles is this right here we know is how much? 90 degrees. Now, a whole triangle is 180. So how much is left right now in the triangle? If I were to take this 90 out, how many degrees are left? 90, because 90 plus 90 is 180, right? So if you have a right triangle that's 90 degrees, you know that these two angles right here also have to add to be what? 90 degrees. So what would I do in order to find the measure of angle 1?
Subtract 30.
Very good. You would go 90 minus 34, and we would borrow, and we end up getting 56 degrees. So measure angle 1 equals 56 degrees. What is another way that I could have found 56 degrees? Mathematically, what could I have done besides that? Francisco.
Add the 90 and 34.
Mm-hmm. And then what? Do you want to help me out, Caillou?
180.
Good. Yeah, so you could also have added 90 plus 34, and you would have got 124, and then taken 180 minus 124, and that would still get you the answer as 56. Is either one of these better than the other? No. Both of them, it's whatever works best for you, okay? So, but the main idea is that all triangles add to be 180. Good. Okay, so number 2. How many of you already have the answer? Okay, I'm going to give you guys about 10 more seconds, if you haven't already, to find the answer. Okay, and does somebody want to tell me how they solve this? So walk me through the steps on how to do number 2. How you did number 2. Okay, Michael.
I circled the right angle and did 90 degrees.
Good.
Then I added 90 and 35 and got 125.
Okay.
And then subtracted it from 180.
Perfect. So you had to borrow, and then you ended up getting what for your answer?
55.
Good. And so, and I'm okay since we're only solving for like one angle, you can just circle that answer, box it. You don't have to write measure angle 1, or you can. All right, number 3. I'm gonna give you guys about 15 seconds to solve for the answer in number 3. Once you get your answer, check with people in your group, see if you guys agree. Okay, does somebody want to walk me through the process? How you solved it? Okay, Devin.
You added up 75 and 54 together.
Okay, and what did you get when you added them?
129.
Perfect. And then what?
Subtracted from 180.
Perfect. 180 minus 129. And when you did that, you ended up getting 51 degrees, which is the correct answer. How many got it right? Outstanding. Good. Okay, number 4. Same idea, right? Okay, how are we going to solve number 4? Okay, let's go ahead. We're going to add 90 plus 59. When we add those together, what do I end up getting? 149. And then what's my next step? Okay, 180 minus 149. And you get 31 degrees. Good. Can anyone do number 5 in their head?
Yeah.
How would you do mental math on this one? Good. 50 plus 50 is easy. Okay, and what is 50 plus 50? 100. And then we know there are 180, so what's missing? 80. Think it's okay to just write that out? Good. You can. All right, 6. What am I going to do?
Add 33.
Perfect. 33 and 28. When you add there, what do you get?
61.
61 is correct. And lastly, I...
Subtract from 180.
Perfect. Okay. And so I end up with
119.
119. Okay. 7 says find the value of each variable. So for 7 through 9, each variable. If you notice, how many variables are there?
30.
There are 3. There's X, Y, and Z. Okay, which variable is the easiest to find first? Very good. And why is that? Good. There's only one angle missing, and they already have those 2 angles. So what will I do first on this? Good. Add 127 and 11. And we get 138. Very good. Okay, now what will I do?
138 minus 1.
Good. 180 minus 138. Perfect. 42. So I'm going to write somewhere that X equals 42 degrees. Now, what would be the next one easy to find?
Z.
Y. Okay, Y is correct. Now, why is Y the next easiest one to do? Shelby.
Because they make a straight line, so you can just subtract 42 from 180.
Exactly it. X and Y together make 2 angles that form a straight line, and we know that straight lines are always 180 degrees. So if I take 180 minus 42, let's go ahead and do the math there, and what do you end up getting? 138. What does that match with? These 2, when you added 127 and 11 together, it equals the same angle as Y. Do you think that's always going to work? Yes, it will actually. And the reason is because if these 2 are a linear pair, okay, supplementary angles, this one is always going, these 2, if they add to be the 180 for this triangle, that means that this angle over here is going to always be that same amount, okay? But you can always work it out if you want to. Okay, and lastly, what will I do in order to find Z? What do I need to do? Good, I have to take my Y value, which is 138, plus the other angle, which is 6. We add those together. We get 144, and then what will I do? Very good. 180 minus 144, and my answer is? Good. So Z equals 36 degrees. Okay, do you guys think you can do 8 on your own?
Yeah.
Okay, you have X, Y, and Z to find again. And once you get your answers, raise your hand. I want to come around and check them. Okay, so check your groups, okay?
I got 117, 22.
Okay. So the answers you should have got were x equals 117 degrees, y equals 63 degrees, and z equals 22 degrees. Do I need to go through either x, y, or z and explain how to get them?
Nope.
Okay, give me a thumbs up or a thumbs down if you're good on this. Okay. All right. Okay, just checking. Trying to check me. All right. So number 9. Let's go ahead and do this one together. What would be the easiest angle to find first? X. And what am I going to do to find x?
72.
Good. Start with 72 plus 18. 90 degrees, which means, do I even have to write 180 minus 90? No. I mean, you can if you want to, but. So x is 90 degrees. What does that mean that y is? Also 90 degrees. Not too much work to show there either. And then how will I find z? 90 plus 32. Good. And then what? Good. 180 minus 122. And so z is what? 58 degrees. Okay? Questions on this side? Do you guys feel better about this kind of stuff?
Yeah.
I heard some of you saying that you don't like this originally, but are we better now?
Better.
Yes? Okay, moving on. Okay, parallel lines and triangles. Do I have somebody that would mind reading this top part out loud for us? Nobody? No one wants to read anymore? Thank you, Carlos.
In the diagram at the right, angle 1 is an exterior angle of a triangle. An exterior angle is an angle formed by one side of a polygon and an extension of an adjacent side. For each exterior angle of a triangle, the two interior angles that are not next to it are its remote interior angles. In the diagram, angle 2 and 3 are remote interior angles of angle 1. The exterior angle theorem states that the measure of an exterior angle is equal to the sum of its remote interior angles. So the measure of angle 1 equals measure of angle 2 plus the measure of angle 3.
And we kind of already talked about this. Do you guys remember how we talked about this in the last example? Not the last example, on the last page. Remember back over here? We were talking about how these matched the values. So remember how we added these two and it equaled 138, and then we figured out that this was 180, and then when we subtracted the 180 minus the 42 that we found for x, it was also 138. And so that's what I was talking about. All right, so it works through your proof here. So you can kind of go through and look at that. I'm not going to read it out loud. And we're just going to go and skip down to the exercises and put this into action. Okay, so it says, what are the exterior angle and the remote interior angles for each triangle? So I'm going to give you a minute to write this down. Okay, so raising your hand, who knows what the exterior angle is? Michael.
4.
Good, angle 4. Good, and then who knows what the two interior angles are? Carlos.
1 and 2.
Perfect, angles 1 and angle 2. So remember that these two opposites, so it can't be one that's on the same line, okay? So it has to be the angles that are not on the line with the exterior. Okay, and so on this next one, notice that there's no numbers inside, so when you're naming an angle, you need to maybe name 3 letters, okay, for some of these. So for the exterior angle, you for sure need to name 3 letters when you're naming the angle. So who knows what the exterior angle would be named? Okay, Cathal.
PON.
Good, angle PON is the exterior. So notice how you go PON. Whatever is in the middle goes in the middle here, and then the 2 outside letters. Okay, so now what about the interiors? since there's no other points with those, you can just label the letters since there's nothing else going off on the sides. So what would be the interior angles? Good. N and angle M. Okay, you're going to do the same thing on 12. I'm going to have you try 12 on your own. So 12 is very similar, to 11. Okay, so what is the exterior angle? MLJ? Okay, MLJ. Did anybody write that differently? You could write it JLM as well, right? Both of those work. Okay, what about the interior angles? Good, J and K. So these, remember, it can't be an angle that's on the same line. Okay, it has to be opposite for the interior. So these two add to be this outside angle. All right, 13. Do you think you can solve that?
Yes.
Okay, I'm going to give you 10 seconds. All right, who thinks they have the answer? Okay, Jordan, what'd you get? Okay, so what two numbers do we add? 70 and 45. So that's a 5, and then 7, 8, 9, 10, 11. 115. Do we agree?
Yeah.
So if these two add to be 115, how much is x? 115. Good. If we wanted to like double check ourselves, we could find what that is and then subtract from 180, but then that takes a lot more time, right? Okay. All right, number 14. Who thinks they know how to find that exterior angle? Nobody knows how to find it. Okay. Okay, how am I going to find it?
By adding 53 and 90.
Perfect. 90 plus 53. So we add, and 9 plus 5 is 14. So what is my exterior angle?
143.
Good. So that would be angle WVT equals 143, or TB. Okay, and the last one, number 15. Okay, so you should be adding 71 plus 46. And what do you get? 117. So that means that angle HGF equals 117 degrees. Do we have any questions?